right, so we're gonna take these one-step equations. We're gonna start applying them to like word problems. Okay, nothing crazy. This video is actually gonna be relatively short. Give you a few examples of how to look at this. One of the big things they talk about is what kind of questions you should be asking yourselves, right? They're giving you word problems, right? So what are they giving you? What information are they giving you? What are you solving for? Does your solution make sense? Right? So let's talk about it. These are like visual aids, right? To help us kind of model how to break this down. And I'll talk a little bit more about what that means. Usually the top represents the total. You either have it or you don't. If you don't have the total, then this stays blank, and things down here are added or multiplied together. If you have a total, it goes up here, and it's going to be represented here on this bottom bar as either subtraction or division. Okay, so let's look at what we got. It says the average cost of school lunch today. So average cost of school lunch today is $4.35. So that's how much each lunch on average today, that's the total that lunch costs. Okay. In 1990, long time ago for you guys, the average school lunch in 1990, the average school lunch was $2.85. Okay. Less than today. Okay. So if it's $2.85 less, how much does the average school lunch cost? Okay, cool. We can work with this. This is perfectly fine. We can definitely work with this. So this is what our total is now on average, right? I know I have to subtract something, right? The cost of what our lunch was in 1990. I'm going to put that here, which was $2.85. What I don't know is how much. I know it was $2.85 less than this number here, but I don't know what it really was. So, because that's an unknown, I'm representing that with a variable, right? So, what does our variable represent? The average school lunch cost in 1990. So, I'm going to say average, if I can spell correctly, school lunch cost in 1990. And then we're going to write an equation, okay? Again, this is my total, so I have to combine these. Combine is a nice word to say I need to add them. So if I'm writing an equation, it's going to be x plus 285 equals 435. Okay, then to actually solve for it, I'm isolating my x by performing the inverse operations. Okay, so there's my variable. It says plus 2.85. I have to do the opposite. So that's going to be minus 2.85 minus 2.85. What I do to one side, I must do to the other. That cancels itself out immediately. Let's do it over here. Now I have 4.35 minus 2.85. Again, my numbers, my decimals, they're all lined up. 5 minus 5 is 0. I can't take 8 from 3, so I borrow from my 4. 13 minus 8 is 5. I drop my decimal. 3 minus 2 is 1. So in 1990, the average school lunch used to cost $1.50. It's actually pretty good. Excuse me. So that's how we're going to be finding solutions with these pictorial models and with these word problems. Okay, let's keep going. Okay, number 2. All right, it says that your little sister is too small to stand on the scale. Okay, so you decide to get on the scale holding her. Okay, you decide to get on the scale holding her, your little sister, right? And find your combined. That's a good one. Weight to be 112 pounds. You know that you weigh 94 pounds. So how much does your little sister weigh? Well, if it's combined, right, that means you and your little sister weighs a total of 112 pounds, right? You definitely know, and it doesn't have to be even. I'm going to make it not even because 94 is a pretty big portion of this 112, so it doesn't have to be split down the middle, right? But we know that you weigh 94 pounds. We don't know how much little sister weighs, so now we kind of have to figure it out, right? So what's our variable represent? Weight of little sister. We can be more accurate. Little sister, right? Perfect. Well, let's write an equation. Almost identical. I have to combine these, which means this should look like x plus 94 equals 112. Well, now I need to isolate my variable by performing the inverse operation. The opposite of adding is going to be subtraction. So I would subtract 94 here, and it cancels itself out. Subtract 94 there. I don't have enough space, so I'm just rewrite it here. We have 112 minus 94. Can't take 4 from 2, so I have to borrow. That's a 0. That's a 12. 12 minus 4 is 8. Still can't do 9. Can't do 0 minus 9, so I borrow. 10 minus 9 is 1. Therefore, x equals 18 pounds. Little sister weighs about 18 pounds. All right. So it's not too bad, honestly. But it does take a little bit of effort, a little bit more focus. All right, I'm gonna do this last one. They're word problems. They're gonna take forever, so I just want to work on a few of them, show you guys some examples on how to plan it out, how to work it out, and we'll go from there, okay? So let's talk about this very next one, rather. It says, number 3, the charge for a microwave repair was $18.21. So the charge for microwave repair was $18.21, including tax. Okay. So if the tax was $6.70, how much was the repair? Okay. Now this one's set up a little bit different, right? We have a quadrant. I know what I need to know, plan and work, and our solution. So let's talk about what we know. They tell us here that a charge for the repair was $18.21, right? That was the total. So I know that my total charge equals $18.21. I know that the tax was $6.70. What do I need to know? Well, I need to know the cost of the repair, I guess, before tax or without tax? Let's say without tax. Now, for our plan and work, okay? So again, I'm just going to draw a similar model to what we have above, a big giant rectangle, and I'm going to split it in half horizontally, right, from side to side. Now, my total, right, my total charge was $18.21, okay? My tax, it wasn't a lot of tax, so I'm not going to give it a whole lot of space. My tax was $6.70. I don't know what that means for my cost of repair without the tax, okay? So let's kind of set it up. I know that if this is my total, I have to combine these. And when I combine these things, I'm essentially adding them, right? So let's go ahead and set it up. I'm going to do that in my solution box, okay? I'm going to do my $6.70, which is my tax, plus my X, which is the cost of the repair without the tax, is going to give me a total of $18.21. All right, cool. Now I need to isolate my variable by performing the inverse operations. If a number is standing like this by itself, it's positive. So in order to get rid of it, I have to subtract. That cancels itself out. Minus 6.70. Again, my place values, my decimals, they are lined up as much as possible. 1 minus nothing is 1. I can't take 7 from 2, so I have to borrow from my 8. My 8 becomes my 7, and my 2 becomes 12. 12 minus 7 is 5. I drop my decimal right there. 7 minus 6 is 1. 1 minus nothing is 1. Therefore, no, wait. Oh, I did it wrong. It's 81. Okay, sorry. Ooh, big old brain fart. Sorry, guys. Real quick. 81. 81. And I'll change this too. We'll rewrite it. I apologize for that. I'm not dyslexic, but I had a moment. 81.21. Okay. And we're just going to continue to do the same stuff. Sorry about that, guys. Still minus 670. Still minus 670, but we have a much bigger number. So, I apologize, right? 1 minus nothing, same thing. Can't do that, so I have to borrow. That's a 12. That's a 5. That's a decimal. Excuse me. Can't take 6 from 0. That's a 7. That's a 10. That's a 4. 7 minus nothing is 7. So, my fault. The cost of the repair, right? X equals, without the tax, $74.51. All right. Yeah, with these kind of problems, you got to be real careful, because even I made that very easy, silly mistake, right? So be very careful. Just keep organized. Otherwise, it might get a little bit more complicated than you'd like it to be. But yeah, pretty simple, pretty short, pretty sweet. That's how you solve some word problems. That's how you represent it with pictorial models. This is the one-step equations application. So this is your ability to apply what we've learned already. All right. Again, hopefully that was helpful. Sorry about the last one. Let's keep going.